So conductance. Conductance is the opposite of resistance. It is how easily an object allows current to flow through it. Okay? Having a good conductance is a very profitable thing. Who can think of a material with a good conductance?
Gold.
Gold?
Copper.
Copper? Silicon's a little bit funny. Silicon does and it doesn't. It's a tricky material. Silver? Aluminium. So most of our metals. Okay. The most common metal that we use for wiring is copper. Okay, and copper is used because it has a number of properties that make it. It's abundant. It's easily formed. It's malleable, and it's got a very good conductance. Okay, so almost all the materials that you have that have electricity running through them have copper in them. Sweet. Conductance. Okay, we look at conducting electricity or not, having electricity run through an object, and we think about what makes it easier and what makes it harder. We've addressed some of the things that make it easier. Having a shorter length of travel. Why would that make sense? Why would it make sense for a shorter length?
Just less electrons need to be transferred?
Yeah, very good. Electrons, when they're passing through wire, do they just go on a nice straight line and they don't run into anything? Is that how it works?
No.
Now, we know from our coil experiment that they run into things, correct? And that causes the wire to heat up, which is a loss of energy. Do power companies want to lose energy? No. So they're obviously trying to minimise the loss of energy, increase their conductance. So they want to have a short length for a number of reasons. It costs less money to put the wires up, and number two, it costs less money to transport. So they're trying to find direct lines between their power stations. Thick wire. Why would thick wire make it easier for electrons to flow?
Greater room for them to go through.
Very good. When we used the example before with the door, so when we were trying to talk about resistance, right? And how everyone was, with the temperature, everyone was moving around. If I had one door, or if I had 7 doors, would it be easier for Liam to get out? 7 doors makes his life a lot easier, correct? He's got more room to move without running into other electrons. Sweet. And the last reason is better conductance in material. And that's, some people have asked some questions about temperature and about all sorts of things about the age and that's all dealt with in the conductance of the material. So each material has its own conductance at a certain temperature. That will vary, and that will vary the object's ability to conduct electricity, or to allow electricity to pass through it. Sweet? So in reverse, what do we think makes it harder for electricity to travel?
Better wire.
Thin? What else? Long wire. Oh, long length, yep. And if good conductance is
Worse.
insulator, poor conductance. I'm going to put conductivity, because we know what conductivity means after last semester. We know that conductivity is describing an object's ability to allow something to pass through it. Sweet. Now it's really, really important we understand this, because, like I said, there's big money in this. There's big money in being able to transport electricity efficiently. You don't want to be losing your energy, particularly when you're burning coal to spin magnets around turbines, etc., etc. There's a fair bit that goes into it. You don't want to be losing that along the way. Does anyone know how they do it? Just curiously. Transformers. What's the job of a transformer? Bump up the voltage. Why would they do that?
So you use less current.
Very good. So you know with Ohm's law, if you increase the voltage, what are you doing to the current? Decreasing your current, correct? If you've got less particles flowing through the wire, are you going to have less resistance or more resistance? If you've got less things, let's think about this room example, right? We can have Liam and 5 people trying to get through this room, or we can have all of you running around and Liam trying to get out. What's easier for Liam?
Less people.
Less people in the room, correct? So less current makes it far more efficient. So at a lot of power spots, sometimes you'll see them on power lines, these transformers. And what they do is you've got one at the power station which amps the voltage right up. Do we want high voltage?
Yes.
when we're plugging our phones into our charger, do we want that to have massive amounts of voltage? No, so it's got to obviously step that voltage back down. So it'll travel most of the distance at that high voltage, low current. It'll then get to the transformer near your house. That'll build up the current, reduce the voltage again, and put it down to a 12 volts or 240 volts, whatever you need.